All right, so we are moving on to special right triangles. And they're called special right triangles um, because of the angles involved in them. There's two different kinds. There's a 45, 45, 90 triangle, which means that there's the 90-degree angle, and then the other two angles are both 45 degrees. The other one we'll look at is a 30, 60, 90, which means there's a 30-degree angle, a 60-degree angle, and a 90-degree angle. And when you have those angles in the triangle, the sides of the triangle have special properties and special relationships. And we're going to be using those today to find missing sides. So yesterday we did Pythagorean theorem, and you use that when you have two sides of the triangle and you're trying to find the third one, and you don't know anything about the angles. What's going to happen today is I'm going to give you one side length and one angle. You have to find the other two. And whatever angle I give you determines what kind of triangle you have and what relationships you have, okay? And I've split this up into 2 days. We're going to do the more simple examples today, on the ones that don't take too much work. And then Monday, we will look at the ones that take a little bit more work to do because they're a little bit more involved, okay? So we're going to start with 45, 45, 90s. And what I'm going to do is we're gonna give these sides some names, and then we'll come over here and look at and give the properties. Okay. So obviously this is the hypotenuse. I'm labeling it height. And then remember we said that the other two sides are called legs. Well, it just so happens that when both those angles are 45 degrees, those two legs are the same thing. So we'll just call them leg. We won't be very creative. Sometimes mathematicians aren't very creative. We'll just call them both a leg. So now we'll come over here and we'll say what the leg is going to be and what the height is going to be. All right. So for any 45, 45, 90 triangle out there, any, doesn't matter how big it is, the leg we'll call X, meaning it can be any number I want it to be. It can be 10, it can be 15, it could be 500, it could be 4 squared 7 or whatever we want it to. It could be whatever we want it to be. The hypotenuse is going to be X multiplied by square root 2. And I say multiply because I'm not showing you the actual multiplication. You need to recognize that when they're next door to each other, just like that, it's multiplication. Remember that for Monday. Okay, not necessarily for today, but remember that for Monday. These two are attached with multiplication. All right? So those are the relationships you'll have. The leg can be any size you want it to be. The hypotenuse is going to be whatever this side is times the square root of 2. Okay, and then we may need to simplify that. So right here, these are the simple examples we're going to do today. And for the 45, 45, 90, these simple cases are where I give you one leg. So I gave you a leg here and a leg here. We have to find the other leg and the hypotenuse. Okay? And what I think is helpful is I like to label the sides of the triangle so that I know what I need to look for and what relationships I need to use. And again, I like to just label what I'm doing off the side. So they gave me the 25, which we know is a leg. Remember, the hypotenuse is always across from 90. And in this case, the 45s are going to be across from the legs. Okay? So 25 is a leg because there's a 45 across from him. Y is a leg, and the hypotenuse is a leg. I want to find the other leg first because, remember, the legs are the same. So if this leg is 25, then this leg is 25. Okay? Now to get the hypotenuse, which is what our x is here, I simply take my leg and put a square root 2 on it. So it's literally just this. And that's it. Now remember, this is technically multiplication going on here, but it's so simple that we can just literally say slap a square root of 2 on the 25. Okay? So here, let's label what I'm going to need to find. Square root of 10 is a leg. X is a leg because that's 45, and this is the hypotenuse. Now notice that up here you had both 45s, but down in our examples you only have one. That's fine. As long as you know that you have a 90 and one 45, we automatically know the other one's going to be 45. Because we could do 180, subtract 90, subtract 45, and we'll get that this one's 45. As long as you know that one of them's 45, you're guaranteed the other one's 45, okay? Don't freak out about not having both. Now, x is a leg, so I know that it's going to be the exact same as this one. Square root 10. The y is, now I'm going to do under here because look what I'm going to have to do. I'm going to have to do square root of 10 times the square root of 2. See, over here, I could just slap them together because that's a regular number and that's a square root. You literally just kind of smash them together is what I call it. Here, it's a square root times another square root. So this goes back to the multiplication that we learned on Wednesday. Sorry, I had to think of the day. So we know to multiply those insides together, so that gives us 20. And now this goes back to what we learned on Wednesday about simplifying using a factor tree, because that is not a perfect square root. So we come over here and do our tree. Let's just use 10 and 2. 10 goes to 5 and 2. So I have 2 2s and a 5. 2 times 2 times 5. Here is a pair of 2s. He gets to come outside. So I have 2 and then my 5 left over. So I want that side simplified, okay? Yes, it is square root of 20. But if you just leave it there, I would take off a point or two because I want the simplified answer, okay? Always simplify your square roots if you can. All right? So that's your 45, 45, 90s. We will save the harder ones for Monday. Okay? Yeah, save them for Monday. Now it's flipped. So that means you'll need to keep this note page and save it for Monday. All right? We're going to use the same one. Now we have 30, 60, 90 triangles we can look at. So notice this time that right here's the hypotenuse. We know that that's across from 90. We still have legs, but notice that the legs are no longer the same length. One of them is shorter than the other one. So I'm going to call him the short leg. And notice that he is across from 30. Okay? So if you go through the triangle to 30, that's where short leg's at. The other leg is across from the 60, and he's longer. So guess what? I'm calling him the long leg. Very creative with my naming. All right, now let's look at the relationships. So we have the short leg. We have the long leg. And then we have the hypotenuse. All right, for your 30, 60, 90s, we always start with the short leg. We want to find him first because everybody else is based on him. Okay? We're going to call him X, meaning he can be any number in the world that we want. Anything we want it to be. 15, 5 square roots, 10, whatever we want it to be, whatever size he wants it to be. The long leg is going to be X multiplied by a square root of 3. Okay? It's no longer square root 2, it's square root 3. The hypotenuse is going to be double the short length. So he's 2x. Okay? These are, for some reason, students generally have a tougher time with this kind of triangle than the other one. And I think it's because they're two different things. Like, this is x squared of 3, this is 2x. They kind of have trouble getting this one. But if we can get the short leg, we can get the other two really easily. Okay? So now let's use those relationships. So I'm going to label what I need to find. Whoops. Sorry, I jumped ahead and did both of them. All right, I'm going to label this triangle again. Now notice they only gave me the 90 and the 60. I'm guaranteed, though, that the other one's 30. And because the 5 is across from 30, and because it's shorter, this is the short leg. Label it SL. That makes X the long leg, and Y is the hypotenuse. Okay? This is the first kind of simple example for a 30, 60, 90. I give you the short leg. And if I give you the short leg, these other two are a breeze to get. Okay? X is the long leg. And remember, the long leg is you take whatever the short leg is, multiply a square root of 3. Okay? Multiply square root of 3. My short leg was 5, so I literally just do 5 with a square root of 3. That's still technically multiplication. I'm just not showing you the multiplication dot. Okay? Y is on the hypotenuse, and up here it says the hypotenuse is 2 times the short leg. It's double the length. So my short length is 5. I need to double 5. 2 times 5, 10. And I'm going to just show you that. That's 2 times 5. Okay? That's easy. You should like this should be really easy for you to get. Okay, this kind. The other easy example is I give you the hypotenuse first. Notice that that now is the hypotenuse. The Y is across from 30, so that makes him the short leg. X is across from the 60, so he is the long leg now. You always have to pay attention to where your sides are located at, and that's why I think this labeling every side is very helpful. If I give you the hypotenuse, your goal is to get short leg first, because you have to get the short leg to get the long leg. All right, so let's find the short leg. I mean, you could sort of do it like this. The 34 is sitting in the location of the hypotenuse, which we know is 2x. So we can kind of do it like this. 2 times something is 34. So we need to divide the 2 off, and that would be 17. That's how you do that. I mean, I sort of do like a little equation here, but you really don't have to. If you can recognize that you need to divide this in half to get short leg, I'm perfectly fine with that. Now that we have short leg, we can get the long leg really easily, because all we do is put a square root of 3 on it. All right? Those are the simple examples. We will save the harder examples for Monday, okay? Because these take a little bit more work. This is where kids struggle, is on the hardest for 30, 60, 90. So I'm going to put all the harder problems on their own day for Monday. Let's make sure we have watched this video all the way through and that you can complete the homework assignment. I think there's just 10 problems, so you should be really short. As always, if you need help, please let me know.